So this is basically just a slide that shows you the amount of sensory data now compared to the amount of sensory data that's available. So what does that mean? What am I talking about? Sensory data. So every human being is sensing their environment. Right now, you're likely listening to me. You may be looking at the computer screen. So now you're using auditory and visual sensory perception. And that's how you get an idea of what is happening around you. So is that idea exactly what's happening? No. No, what is happening around you is subject to your mind's ability to filter and frame your situation, right? The perception and experience is filtered and is framed through the human mind and the human brain. So what that slide was pointing out is that in the 15th century, you didn't have a lot of stimuli. You had your normal stuff, nature, you had the sounds of the working village, maybe, like hammers and wagons or whatever. But today, in the modern era, we are literally being bombarded with stimuli. So our cell phone, the TV, just people everywhere, these days, especially if you're living in a big city like Chicago, where I live. There are literally people everywhere. I had a friend that lived in India, and he said, forget Chicago, you know, it is nothing. And then he actually showed me a video. He held up his cell phone while he was in traffic, and he was not lying. It looked like a million person march or something, but it was literally just Thursday afternoon at 4 p.m. and there were people shoulder to shoulder, neck to neck, cheek to cheek. And it was, wow, okay. So now more than ever, the human being is being bombarded with so much sensory data. And now just think of probabilities. So what is a probability? 0 to 100%. 0% means that this can't happen. 100% means that this is guaranteed to happen. Well, in statistics, we don't really deal with 0 and 100. We're somewhere in between those things, usually. So the the percentage, the sheer percentage of incoming stimuli, which you could call data, right? It's information that's coming in to your field of awareness, and your brain is taking, or your sensory organs are receiving it, and then it is translating it into chemical messengers, and then the brain is translating those chemical messengers to create a picture of your environment. Every human being, every animal, in fact, is doing this. It's pretty much the way that it is, and that's cool. So we have all of the stimuli coming in, and that is affecting the probability cloud, right? In the 15th century, you had much less information, much less stimuli coming into your bubble. And so, that's not that bad. I can kind of sift through that. But now it's not the same. There's so much information coming in that is directly impacting the probability of where your attention is going to go. Where is your attention going to land, and for how long is now just being left to all of the data and stimuli that's influencing that probability field or probability cloud. Okay, so going back to my PowerPoint. All right, so let's see what the next page has for me. And so in my book, I get into this in great detail because it's really important. In psychology and neuroscience, we do have a term for this, and it's called continuous partial attention. And worse than just being partial, it is not chosen. It is just a direct result of the probabilities of where your mind goes most often, what it's most easily pulled by. And so doing this is essentially like a laser beam. If a laser beam is focused, it's very powerful. It can cut through things. But if a laser beam is scattered in a trillion, 1,000 different directions, I don't know why I said a trillion. That's a big number. 1,000. Okay. So it's in 1,000 different directions. It's not going to have the same capability. It's not going to do what it can when it's a single laser beam of energy. And so when attention is continuously partial, well, guess what? We've done studies on this. We've done research in the United States on the impact of attention when it's constantly partial and constantly being divided and constantly switching tasks. So there's also a term in psychology, and we'll get into that later, but when the mind is constantly switching from one task to another, and I mean constantly, like every second, every half second, the mind is just rapidly going from one thing to another, there's a metabolic expense. So it's actually using our metabolic energy, our ATP. ATP is the chemical energy that we use to exist. Without that, there's no human being as we know it. There's no human being without ATP. That's our chemical energy. So continuous partial attention, and we can show this through different studies that it has a huge impact on our ability to perform. It has a huge impact on our ability to do things like scheduled work, focus on certain things, set boundaries. So when you sit down and you're like, all right, I'm going to study this subject for 30 minutes, and literally 2 minutes later, you're looking at your cell phone, or you're looking over at somebody else's conversation, or you're wondering what you're going to have for lunch, or you forgot what you had for breakfast and you're trying to recall. But the point is that the mind has wandered, and then it's continuously partial. It's not quite focused on a single or even two things. Like, let's just put it to two things. It's still scattered. It's still fragmented. And then so when this happens, the mind is less organized. The mind has trouble navigating that probability. It's literally just a cloud that is at the mercy of the currents of the wind.